When your car won't start, it's sometimes painful to admit the problem was caused by human error, such as forgetting it needed a tune-up. Of course, mechanical problems are not always the fault of the owner. Sometimes trouble gets built in at the factory. And again, the reason is often human error. And there's a very good explanation: repetition, tedium, and fatigue. For example, history can offer some of the classic results of mistakes, such as a rocket that went up in smoke instead of space, or a suspension bridge designed to last a century until a storm turned it into silly putty. Oh well, back to the drawing boards. Of course, most bridges stay put. Most rockets make it into space, and most cars start when you turn the key. The big problem really isn't the big mistakes. It's the millions of smaller ones that occur in design and manufacturing each year. Together, they result in fewer goods, higher cost, and lower quality. America, while remaining the wealthiest nation on Earth, has slipped to 4th place in productivity. What's the answer? Well, part of it may be a new technology known as Cad Cam. This is one of the latest ways to design something right the first time, developed by Calma in Sunnyvale. It is a very fast, powerful computer, and it is linked right over here to a high-resolution television monitor. This is the CAD part of Cad Cam, and it means computer-aided design. This electronic pen is connected to the computer. When the pen is moved over this special tablet, a point can be moved over this screen. Enter 2 points, and there's a line. Before you know it, you're designing. Now, we want this to be a 3-dimensional object, so we tell the computer to give it depth. And the people who will build this widget want measurements, so we do that. And the final version has to include 4 different angles, so we do that too. A CAD system lets the designer concentrate on the creative decisions, while the computer does all the time-consuming, repetitive work. And some jobs are really repetitive. Another computer is programmed to design some of the most complex objects in modern technology, the tiny electronic integrated circuits used today in everything from digital watches to satellites. Integrated circuits contain thousands of microscopic transistors, almost all of which are identical. They have to fit together perfectly before the circuit will work. Doing this same design work by hand would take days and be prone to costly mistakes. The CAD system lays out the entire circuit in seconds with perfect accuracy. And now for the final chapter. CAD systems can be used to convert designs into automated machine operations that will manufacture what we draw. Let's say we want to mass produce a new line of carved aluminum candlesticks. First, we create the design. Now, because the candlesticks will be mass produced on a metal lathe, we'd like to have that operation computerized. So, we tell the computer to create the proper lathing operation conforming to that exact design. Besides being displayed visually, the lathe operation can now be converted into numbers that will actually control the machine. This is a paper punch tape. It contains a series of coded numbers that will guide the metal lathe. This tape can be sent to an automated machine shop anywhere in the world, and this is what will happen. This is a computer-controlled lathe. It's cutting to the exact specifications of our punch tape. An operator still controls things, but from a much safer distance, and with greater speed and accuracy. Besides building better candlesticks, many people believe that Cad Cam technology will play an important role in helping America improve its industrial productivity and its strength in the world economy. It's already helping other nations, For example, 1 out of every 4 CalMA systems is exported to Japan.